What's up guys, Nat here. Today we are gonna build DIY UV LED exposure box. So we made this exposure box because every project in our school needed a name and it should be printed in PCB. Here's a short clip on how it works. It runs on a 12-volt DC power supply and has a timer for the buzzer to indicate if the exposure is done. And for safety, a ridge switch is placed in the power line of the LEDs so that our eyes won't be exposed to the UV light. Here are the electronic components we will be needing, the tools, and the materials for the case. Here's the circuit schematic. We'll go into detail on the next video and in the website, but to give you guys an overlook of the schematic, the circuit can be split into two parts, the LED circuit and the 555 timer circuit. The reason why we use the 90 ohm resistor for the LEDs and why there's an op-amp in the 555 timer circuit is in the website and in the next video. First, we will put some solder lead to the buttons and the supply port, then solder down some wires. Then we will put some solder lead to the ends and the ends of the rotary switch, solder a wire to the end, and cut one leg of each of the resistor to reduce its length. Then we solder the small leg to the rotary switch, then we solder the resistors together with the wire, and lastly, check if it's good to go. We will now solder the components of the 555 timer circuit to the PCB board, starting with the IC holder, resistors, capacitors, then the buzzer. Now we place wires on hard-to-reach connections in the schematic. And lastly, solder all the buttons and the plug for the power supply to the board, and then we are good to go. Now let's make the UV circuit, the most important circuit in this project. Firstly, you need to plan how you will place all the LEDs. The PCB we were able to get a hold of was this kind of PCB. We place our LEDs in a zigzag formation, then tape and bended the legs, then solder. Lastly, we place and solder the resistors to the board, and when we completed soldering half of the LEDs, we did a test run using the 9-volt battery. After another strip of LEDs, we used the power supply again to test until we finish and have all of the LEDs working. We connected both PCBs, the UV LEDs and the 555 timer circuit, then connected it and tested it, and as you can see, it is now good to go. For the case, we use a shoebox since it already has a lid and it's already a box. We drilled holes for the buttons and power supply port. We also made a divider for the division of the UV LED PCB and the 555 timer circuit. Also, the reed switch is placed on top of the divider with the magnet on the lid. So as soon as the box is open, the LEDs won't emit the UV light. We use a bolt and a bolt holder to be the legs of the acrylic. The acrylic is in a height of 10 centimeters from the LED. Don't put them too close because of overexposure. For the test, we use all of the 5 time settings in the 555 timer circuit and found that the 30 seconds UV light gives the best exposure in terms of time. All of the other PCBs were overexposed. With all that is done, I'll be posting my next video on the story, how to troubleshoot it, and I don't know, life lessons learned. So anyways, thank you guys. If you stayed up to this long, you are awesome, and leave a like if this video deserved it, and comment down below if you need any help, or you can reach out to me via Instagram or via email, and subscribe if I deserve it. Anyways, bye.